Let's continue with the next problem. See the third one. Show that each of the relation R in the set A given by that one, given by, there are two sub questions. R is equal to A comma B such that mod of A minus B is a multiple of 4 and R is equal to A comma B such that A is equal to is an equivalence relation. Now, when we say an equivalence relation, remember it has to be all the three, reflexive, symmetric as well as transitive. Only then you can say that it is an equivalence relation. Correct? Now, here we have to prove that both, that is the first one and the second one, both of these two are reflexive, symmetric as well as transitive. Now, only if you prove that, then you can say that it is an equivalence relation. Let's start with this one. So first we'll write down what is set A, because what they're saying is set A. So the third one here. Now set A is basically 0, 1, 2, 3, so on and so forth till 12. Correct? Now first is R. So first sub question in this one. R is equal to A comma B such that A comma B is a multiple of 4. Correct? So you can start by taking 0 comma 4, 4 comma 0, 1 comma 3. Oh, sorry, 1 comma 3 is not possible. 1 comma 5 is possible because it's A minus B, right? 1 comma 5, 5 comma 1, or you can say 2 comma 6, 6 comma 2, so on and so forth till 12 comma 12. This is like you have a lot of numbers in this one, like relations you can call it. Okay. Now with this set where mod of A minus B is a multiple of 4, first let's calculate whether it is reflexive or not. Alright, so the first one, that is, we'll talk about reflexive. Now for the reflexive part, now what we can say is that if you take R, or if you take any two numbers, I would say, a pair of this thing. For reflexive, what do we have? A comma A should belong to R. This is what when we say that it is reflexive. Now, in this case, if you take any number which is present in set A, irrespective of whether it is even, odd, multiple of 4, non-multiple of 4, whatever it is, if you take the same number, because A comma A, right? That means if I take a number, let's say 3, then what do we get? So if you take 3 comma 3, then this will be nothing but mod of 3 minus 3, which is equal to 0. 0 is a multiple of 4. Or if you take a multiple of 4 itself, say 4 comma 4, this is also 4 minus 0. 4 minus 4, which is 0, which is the multiple of 4. So what we can come to the conclusion, the end part, is that irrespective of what number we choose from that set A, it is always going to be reflexive. Correct? So we can say at the conclusion, we can write that this implies that R is reflexive. Correct? R is reflexive. So first part is done. Now we'll come to the second part, that is this being transitive, symmetric. Alright? Now for this to be symmetric, see now what we have, suppose if you have A comma B belonging to R, then B comma A should also belong to R, correct? This is what we mean by it. Now first I'll give you few numbers example, then we'll do it in a general case. Okay, so here suppose if you take a number, okay, let's say you have 1 comma 5. 1 comma 5 is what? Mod of 1 minus 5, which is nothing but 4. So we also have 5 comma 1, which is nothing but mod of 5 minus 1. 4, isn't it? So both 1 comma 5 as well as 5 comma 1, they both belong to the set R, correct? Because remember, we had written one huge set number, the list of all the sets, what we have, the relations. So in that we have this one. Or you can also take another example. Okay, another example. Let's say you can also take 3 comma 7, mod of 3 minus 7, which is 4. Also 7 comma 3. This is also equal to 4, which you can say that it is a multiple. Correct? Now from this you can directly tell that R is symmetric. But if you have to prove it in general, then you can say that, see this one, A minus B is nothing but mod of A minus B, which is equal to 4 times of K being some integer. So you can say that K belongs to Z. Now if you do B comma A, so this is A comma B, B comma A is equal to mod of B minus A. Now you can also write this as mod of minus of A minus B. Now modulus of a negative number is the same as the number itself. So you can write this as mod of A minus B itself, which you know that it is a multiple of 4, isn't it? 4 into K. So what do we say? That in turn, mod of B minus A is also a multiple of 4. So in general, this is what we can say. So what do we conclude from this? We can conclude that this implies that R is symmetric. Now the last part, which is R being transitive. So now for what do we have? R is transitive. See, for R being transitive, what is the condition for it to be transitive? If you have A comma B and B comma C belonging to R, then A comma C should also belong to R. This is the condition, correct? So now here we'll take few examples and we'll do it. See this one, 1 comma 5, this belongs to R. 5 comma 9 belongs to R. So 1 comma 9 should also belong to R. Now let's test it whether that condition holds good or not. If you have 1 comma 5, this is mod of 1 minus 5, which is 4, multiple of 4, well and good. If you take 5 comma 9, mod of 5 9 minus 9, 4, multiple of 4, fantastic. Now if you take 1 comma 9, mod of 1 minus 9, which is 8, 8 is also a multiple of 4, isn't it? So we can conclude that R is transitive. Now, you guys can do it for general case also. Like, how we did it for symmetric, like that one. Alright, so at the end, we can say that R is transitive. So we have proved that R is reflexive, symmetric, transitive. So in the first case, you can say that here, this one, it is an equivalence relation. Because we just proved that it is all the three, reflexive, symmetric and transitive. Now we'll go for the second one, that is A is equal to B. Alright. For the second one now, we have relation R is equal to A comma B such that A is equal to B. Isn't it? See, when you have A is equal to B, it's very, very clear that it is reflexive. Because for it to be reflexive, the first one, what is the condition? A comma A should belong to R, isn't it? Now, when you take any number, like if you take A comma A, then my condition will be A is equal to A. Every number is equal to itself, isn't it? So there is no need of taking any examples whatsoever, because you know that every number is equal to itself. So R is definitely reflexive in this particular case, correct? So you can directly say that R is reflexive. Now remember why we are saying that R is reflexive here? Because every number is equal to itself. So whether you're taking the set of 0 to 12, these numbers, or any other numbers, the set or the relation always holds good. So the first one is done, reflexive is done. Now we'll go for symmetric. Now you have symmetric. See, for this to be symmetric, what do we have? If A comma B belongs to R, then B comma A should also belong to R, isn't it? This is, the set or the relation being symmetric. Now if you take A comma B, that means if you have A comma B, then what do we get? A is equal to B, isn't it? A is equal to B. If you take B comma A, this is basically saying B is equal to A. A is equal to B, B is equal to A. Both are one in the same, right? That means what can we say? That if A comma B, if A comma B belongs to R, then B comma A belongs to R. If A is equal to B, then B is definitely equal to A. This is what we have. So what can we say from this? This implies that R is symmetric. R is symmetric. Very easily done. Now the last one, transitive. Transitive condition. See, we have transitive. So now, what do you get? So you have to have A comma B, B comma C. These two should belong to R. Then A comma C should belong to R. Correct? This is what we have for transitive condition. So let's look into this one. If you have A comma B, this implies A is equal to B. Correct? And if you have B comma C, this is nothing but B is equal to C. See, if A is equal to B and B is equal to C, so can we conclude that A is equal to C? So what we can say, this implies that A is equal to C. Don't you think that's nothing but A comma C? So we have A comma C is nothing but A is equal to C. Correct? So what can we say? That R is transitive. So when you have all the three, what can we say? That we can say that this is an equivalence relation. So we proved that both of them, the first one and the second one, both of them are equivalence relation. Understood? So this is how you need to do it. You need to do for reflexive, symmetric, transitive, all the three, and then you can prove that it is equivalence. Now let's do the fourth question now. Fourth one now. Show that the relation R defined in the set A of all triangles as R is equal to T1 comma T2 such that T1 is similar to T2. Okay, now here pay attention. T1 is similar to T2, isn't it? Is an equivalence relation. Now equivalence meaning reflexive, symmetric, transitive. Consider three triangles. T1 with sides 3, 4, 5. T2 5, 12, 13. T3 6, 8, 10. Which among the triangles are related to one another? Alright, fine. Let's do this one. It's quite easy. Now remember, when we say equivalence, you need to prove that it is all the three, reflexive and then symmetric and transitive, correct? You need to prove all the three. So first what we'll do, we'll talk about reflexive. First we'll talk about reflexive. So here A comma A should belong to R, isn't it? This is the condition. So when you take triangle T1, so T1 belongs to R, correct? Or T1 actually belongs to A set of all triangles. So when you take T1 comma T1, so that means what you're saying is that T1 is similar to T1. Now every triangle is similar to itself, isn't it? So T1 is similar to T1, or you can say same thing, you can write it on words also. That is, every triangle is similar to itself. So what can we say? Hence, R is symmetric. Sorry, R is reflexive. So R is reflexive. This is done. Now we'll do the same thing for symmetric. Symmetric. For symmetric, what is the condition? If A comma B belongs to R, then B comma A should also belong to R, isn't it? This is the condition. Now let's solve this one. It's very easy. See, if you have T1 comma T2, so this implies T1 is similar to T2, correct? Now if you do T2 comma T1, this implies T2 is similar to T1. Don't you think that this is true? Because if T1 is similar to T2, then obviously T2 should be similar to T1, correct? So what can we say from this one? So we can say that R is symmetric. Now we'll do the third one, that is the transitive part. Now what we have, if T1 comma T2 is present, that means we are saying T1 is similar to T2, right? And if you have T2 comma T3, this means T2 is similar to T3, correct? So what we need to have in the set? T1 comma T3, which is nothing but T1 is similar to T3, correct? See, if triangle 1 is similar to triangle 2 and triangle 2 is similar to triangle 3, then triangle 1 is similar to triangle 3. You have learnt it also, isn't it? So what can we say? That if T1 is similar to T2 and T2 is similar to T3, then T1 is similar to T3. That means this implies T1 comma T3 belongs to R, isn't it? So if T1 comma T3 belongs to R, don't you think that's exactly this is what we are trying to prove. This is what we are trying to say, that it is transitive. So we can say that R is transitive. So what do we say at the end? We can say that therefore R is an equivalence relationship, or you can say an equivalence relation. Now coming to the next part. See, the next part we have sides, correct? So we'll look into that one. We have T1 with sides 3, 4 and 5. Now when you have 3, 4, 5, you know that this is a right angle triangle, correct? It's a right triangle. Now the second one, T2, is 5, 12, 13. This is also a right triangle, isn't it? Then the last one is T3, which is 6, 8 and 10. This is also a right angle triangle. Now what we have is we have three right angle triangles. Now between these three, which two are related? We have to look into it. Now we know that when the triangles are similar, their sides are proportional, correct? So that means when, suppose if you take T1 comma T2, then T1 should be proportional. Sorry, T1 is similar, so side should be proportional. That means 3 by 5, 4 by 12, 5 by 13. Are they in the same ratio? They are not in the same ratio. So T1 and T2 are not related. Now let's look into T1 and T3. So if you do T1 comma T3, that means T1 is similar to T3. Let's look at the side ratio. 3 by 6, 4 by 8, 5 by 10. Now these three are equal. The ratio is half. So we can say that T1 is related to T3, correct? So T1 is related to T3. So this is what we can say. Understood? This is the answer for the fourth one. Now let's solve the fifth one. Show that the relation R in the set A of all the books in the library of a college given by R is equal to X comma Y such that X and Y have same number of pages is an equivalence relation. Because we have done similar to this one. Remember that A is equal to B. It's the same thing but given in a different form. That's all. Alright. Now I want you guys to solve it because it's the same thing. Go ahead, pause, write all the steps reflexive, symmetric, transitive, and at the end you guys can check whether whatever you have written is right or not. Alright, please go ahead, pause and solve by yourself. This one, see here, first what we'll do, we'll look into or we can just write the relation first. See, we have R is equal to X comma Y such that I'll call X is equal to Y. Where I can say that it is nothing but the number of pages in the book. Alright. So first we'll do reflexive. So for the reflexive part, so what do you have here? X comma X. This is nothing but X is equal to X, isn't it? So you can say that every book, that means if you take some book, whatever it is, every book is obviously related to itself because the number of pages, if you have 100 pages in one book, obviously the book is related to itself, correct? So every book is related to itself. So you can say that this implies R is reflexive. First part is done. Now we'll do the next part, that is symmetric. So for symmetric, what do you have? If you have X comma Y, this implies X is equal to Y. And if you have Y comma X, this is nothing but Y is equal to X. Come on, if X is equal to Y, then Y has to be equal to X. Correct? So what can we say from this one? This implies that R is symmetric. Correct? Now the last part, transitive. So what do we get for transitive? If you have X comma Y, this is nothing but X is equal to Y. Say Y comma Z, that means Y is equal to Z. So if you have, see this, if X is equal to Y and Y is equal to Z, so we can say that X is equal to Z, isn't it? So if you have this, then X is equal to Z. This implies X comma Z belongs to R. So what can you say? This implies R is transitive. R is transitive. So at the end, what can you say? Therefore, R is an equivalence relation. R is an equivalence relation. Got it? So this is how we solve these problems. Fair enough? So in the next video onwards, we'll look into the different topic.